Hello, sixth grade math teachers. I hope you all had a wonderful summer. And we are splitting up into different subjects and grade levels so you guys can get professional development for your content in your grade and not just listen to something that has nothing to do with you. So today we are going to be learning about backward design. Have many of you guys heard of backward design? Okay, as I see, some of you guys had them as an assignment in class that you took, whether it was in college or you learned about it or you automatically do it in your class right now. So let's go ahead and get started. We're going to get started with this video that explains what backward design is.
Imagine this. A group of friends decide to organise a day out. Katie is excited because she thinks a day at a folk festival would be perfect. Sam is excited because he sees everyone heading out of town for a long, peaceful bushwalk. And Sue is excited because she imagines the group visiting the snowfields and having their first ever ski lesson. The group arranges a meeting time, a place, then get busy with their own lives. On the appointed day, the three friends meet, pile into the car and set off. As time passes, Sam becomes grumpy because the group keeps driving past all of the exits to the best bushwalks. He wonders why he has his hiking boots on. A bit later, Sue becomes grumpy because Katie has turned off the highway away from the snowfields, and Sue is regretting putting her thermals on this morning. She wonders why she has been working so hard on her quads at the gym. An hour later, Katie pulls the car over and lets her friends know that she is lost. By the end of the day, none of the friends have achieved their goal. What if the three friends approach their day out differently? Katie, Sam and Sue get together to chat about what they would like to do. They decide on a common outcome for the day, plan what each will need to do to get ready, and what the group will do together to make sure the day out is a big success. As the weeks go past, the group talks often to make sure everyone is moving towards being able to participate in the day trip. Katie gets used to using contact lenses, while Sam buys a new wetsuit, and Sue speaks about working on her swimming skills. The group also plans what they will need to take, book the surf school, and organise how they will get to the beach. On the nominated day, the three friends meet, pile into the car, and set off. They reach the beach in time for their lesson and have a terrific day together. Backward design is like the second scenario. Teachers start unit planning with the end in mind. They consider the outcomes of a unit of work before mapping out how each individual student, and therefore the entire class, will get there. This way, the learning and teaching in the classroom gives every student the opportunity of reaching the final destination.
Okay, so now you have an idea of what backward design is. So basically you start with the end and then you work your way backwards. So another example would be any sports team. Let's just say volleyball, because I know everybody wants to say football, but let's just say volleyball. What does every volleyball want to do? Every volleyball team wants to do, excuse me. Every volleyball team wants to go to the state championship, or any team at that wants to go to the championship. So we start with winning in the beginning, and then we work our way back. How do we do that? Well, we have to go to regionals, and then we have to go to by district, and then we have to win district, and then we have our regular season. So before the season even starts, we have preseason, and we have to do practice. We have two-a-days. We have scrimmages. We do different things like that. So it all starts with the end in mind, which is a championship, and we go all the way back to, let's say, the ending is tryouts, because that's when it all starts. Okay, so these are the 3 stages of backward design. I'm not going to read it all because I know how you guys are. You guys are probably just ready to go, but I promise I just have about 5 more minutes. That's it. Just give me 5. Okay? So number 1 is you're going to start off with the desired results, which is what I said, i.e. the championship in volleyball. You're going to determine acceptable evidence of learning. Are we winning or are we growing? And you're going to plan learning experiences and instruction. This falls back on me. Am I running practices correctly? Am I doing drills the way they should be? Am I executing different things to make sure that we get better as a team? Okay, so now we're going to get specific on your TEKS. So one of the TEKS says, represent benchmark fractions in percent, such as 1%, 10%, 25%, 33 and 1/3%, and multiples of these values using 10 by 10 grids, strip diagrams, number lines, and numbers. And 5C, use equivalent fractions, decimals, and percents to show equal parts of the same whole. Are there any questions on what any of these words are? I know we have some new teachers, some people who are on probationary contract, and some people who went to a different program, so they might not know everything. If you don't know, it's okay. Just raise your hand. Okay, strip diagrams, they're actually on your table in your bucket. There's strip diagrams in the bucket. There's a number line. There's a 10 by 10 grid. And there's also equivalent fractions on your table as well, just in case you need to reference to it. Okay, so we're about to get started. So these are examples of a strip diagram, and this is an example of equal parts of the same whole. So as you see, for the strip diagram, it is in a deep violet color. That is a whole. You see it at the top, and you also have it on your table, remember, if you need to look at that. And then as you go down, you'll see that the denominator increases, but the numerator stays the same. So I'm going to give you a second to look at that. Okay, so let's just say this. Let's just say one whole is our ending factor. That's the backward design. So we're going to start off at one whole. So where do you think we would end at? Okay, I had someone say at the bottom at 1/12. Does anybody else have anything else that we could add? Yes, because fractions go higher than 1/12. So this is just an example. You can add more if you would like, but let's just stick with this strip diagram so everybody's on the same page. So as you can see, you can cut up these pieces. So I'm going to give y'all a few moments to start cutting. And while y'all are cutting, I want you to have a discussion on how you can create a backward design with these strip diagrams. I'm going to give y'all about 10 more seconds. Okay, so as you can see, we need 2 halves to make a whole, 3/3 to make a whole, 4/4 to make a whole, and so on. So basically what your denominator is, it needs to be the same as the numerator. So if it's 5/5, that equals a whole. So you could say, you can use the same thing with money. So you have $1 and you could break it down. What's the first thing that people are probably going to try to break it down with? A quarter. So it'll be 4 quarters. And then you can break it down into dimes. It'll be 10 dimes. You can break it down into pennies. It'll be 100 dimes. So as you can see, models and manipulatives are very good to start off from the beginning and then work your way back to see how it represents as a fraction. And so as mentioned in the TEKS, it's 1%, 10%, 33 and 1/3%. It could be represented in many ways. You could use food. You can use manipulatives. It doesn't have to just be paper. Okay? So equal parts of the same whole. As I just mentioned, we were talking about food. So as you can see, these wholes, what is something similar to the wholes? Yes, pizza. Everybody loves pizza. And whenever food is integrated, you can best believe the kids are going to be listening. So you could just say, okay, how many equal parts do we need to where it's the same whole? Just because it looks like, let's look at the 5 equal parts. Just because it's 5 equal parts on the rectangle doesn't mean it can't be 5 equal parts in the pizza. It might not look the same, but it's still 5 out of 5 or 3 out of 5. It's different fractions and different equal parts that can equal to the same whole. It's just a different picture. And so as you can see, design and pictures and different things like that can help people understand. So just remember to work with the endpoints in mind first, and then go all the way back to the basics. I find that way easier, and the district's trying to adopt it. And so we're going to adhere to the best research that's going on. And if anybody has any questions, comments, or concerns, you can ask me now, or write it on the sticky note on your table, or come by my office, whatever works, and I hope you enjoyed it. Thank you.